Hi, in this video we're going to be looking at the second topic of P2, which is electrical currents. So here's what you need to know. Three main equations. V equals I times R, which is voltage equals current times resistance. So I'm assuming you're probably familiar with the triangles. If you want to know what voltage is, you cover voltage up and times the bottom two together. Remember, this line effectively means times and this one effectively means divide. So if you want to know what current is, cover up current, and current is voltage divided by resistance. And if you want to know what resistance is, cover up resistance, and resistance is voltage divided by current. So you could be asked to figure out any one of those. This one, power equals voltage times current. So you might be asked to work out the power of an appliance by them giving you the voltage and the current. Or you might be given the voltage and the power and asked to work out current. Same idea, remember this line means divide and this line means times. So power equals voltage times current. Voltage equals power divided by current, and current equals power divided by voltage. And finally, energy equals voltage times current times time. But we know that voltage times current is power, so that's the same as power times time. Same idea, if you're asked to work out the energy, cover up energy. So energy equals voltage times current times time. Or another example, if you are asked to work out voltage, energy divided by current times time. Okay, fairly straightforward, good. The other thing you might be asked to do is to draw a series or a parallel circuit or to complete them. So a series circuit, remember, means everything in one loop. So a cell with maybe an open switch, a bulb, and one thing you're commonly asked to do in a series circuit is put an ammeter in. Okay, so an ammeter goes in series, it goes in line with the components because it measures how much current is flowing through. So the current has to go through the ammeter for it to measure how much current is flowing through. You might also be asked to complete or draw a parallel circuit and commonly asked to put a voltmeter in. So a parallel circuit, remember, is one with more than one loop. So for instance here, I'm going to put the switch in again, put the bulb in, and then a voltmeter must go across the component that you're interested in. And we will we'll look at the definitions now to see why that's important. So current, as we discussed in the last video, is the rate of flow of electrons around a circuit, and voltage, also known as potential difference, is the difference in electrical energy carried by the electrons before and after flowing through a component. So it's the difference in energy between this side and this side, because the electrons flowing around the circuit give over energy to operate the component. So for instance here, the electrical energy is converted to light energy in the lamp, which means the electrons entering the component have more energy than the electrons leaving the component. So voltage or potential difference is the difference in electrical energy carried by electrons before and after flowing through a component. Before and after flowing through a component. Okay? Other things you might need to do are identify circuit components. So we talked about the cell here. When you've got more than one cell together, it's a battery. If you've got a rectangle without the wire flowing through it, you know you've got a resistor of some kind. This is a variable resistor. This, as we've already discussed, is a lamp. This one here, triangle with a bar on the end of it in a circle with the line going through it, is a diode. If it's a light emitting diode, you'll have lines, you'll have arrows coming off it. Here we've got an ammeter, we've already seen that up here. And this, the rectangle with the line going through it, that is a fuse. Right, one other thing you might be asked to do in the electrical currents part of the topic is interpret or maybe even draw a graph of how current changes with voltage for particular components. So if the line looks like this, so a straight diagonal line, so as voltage increases, so does current, that is a fixed resistor. Okay, so looking at this relationship here, if as voltage goes up, so does current, as this is doing here, the resistance must be constant, so that's a fixed resistor. Another common one is a line that looks like this, so it starts off flat, gets steeper, straightens off for a bit, and then flattens off again. So if we just look at the positive section of the graph here, what we've got is that as voltage increases, current increases proportionally to start with, but then as we get into a higher and higher voltage, the line flattens off, so it's harder and harder to push a bigger current through. So what that implies here is that our component is getting warm because it's taking more and more energy to get the electrons to flow through. What component gets warm as it's used? A filament lamp. So that is the line for a lamp. And then one other fairly common one. So if we've got zero current on one side, when the voltage is pushing one direction, we've got zero current. And then on the positive side, shortly after zero, we get a steep increase, so a curve at the bottom and then flattening off. What that's saying is that current can't flow in this direction, but after a certain point, a certain sort of threshold voltage, current flows really, really easily in one particular direction, and that is this here. So that is the line for a diode. Okay, let's just check we know our units. So voltage or potential difference measured in volts, current measured in amps, resistance in ohms, that's an omega for that. Power, what's the unit for power? Poor joke, watts. And energy is measured in joules. Okay, good luck with P2.